1.6, reflections, absolute values, and other transformations. This is pretty much review. We've done a lot of this, and now I feel like this is more review than anything new. Okay, so our essential question. Given a function, how do you transform it by reflection and by applying absolute value? To the function or its input. I'm going to add one more here. I want you guys to learn the difference between an even and an odd function. So let's just put what are even and odd functions. Okay, so the first part of these notes, I say recall transformations from 1.3. So 1.3, I gave you this really nice table that I found. And you probably should pull that out, and it might be helpful, or you might want to even write some of this stuff down in these notes, but I didn't think I needed to recreate this table. So a lot of the transformations that we're going to go over today, we've already gone over. So negative f of x, you reflect f of x over the x-axis. F of negative x, you reflect f of x over the y-axis. And then the absolute value is a reflect across the x-axis any negative output. So those are what we're going to go over, and nothing really new here. Okay. So onto this property, this pretty much just repeats exactly what I had in this table. But again, I think that table is really valuable, and I would know everything in that table. Okay. But basically it says, you know, if g of x equals the opposite of f of x, and we're going to use that negative as opposite, okay? It's a vertical reflection of a function f across the x-axis, okay? So here's our equation here, or sorry, here's our original function, okay, our pre-image. Okay, this is going to be f of x. And so g of x is when I take all of those outputs and I take the opposite of them. So here my output is what, like 2? Well, now I'm taking the opposite of that, so negative 2. Okay, let's say that this output at 4 is 1. Well, my output is the opposite of it. Okay, so it's negative 1. Okay, or this one here at 2, my output was 5. Well, when I do the opposite of f of x, so for g of x, you're going to end up with negative 5. Okay, so we can call this our g of x function. Okay, and maybe just to differentiate, maybe we'll call this one h of x. So maybe put h of x in there. Okay, so if I do the opposite of my original input, well, it's a horizontal reflection of function f across the y-axis. So think about it. Originally, my x's, let's say, were all positive, and then I decided to do the opposite. So I made them all negative. Okay, so that's basically a reflection in the y-axis. So for example, 5 was my original input, and instead now it's going to be negative 5. Well, negative 5 is my input. I'm going to get the same output as 5. Okay, so it's just a reflection over that y-axis. All right, so we'll call this h of x. Okay, just trying to differentiate a little bit there. All right, so let's do an example here. So we have the preimage function, which is y equals f of x, in figure 1-6a. Okay, and so this is the figure 1-6a. It's up here. So I actually did it for us. I gave us a picture of it. And it's f of x equals x squared minus 8x plus 17, where our domain is between 2 and 5. Okay, so for 8, we're going to write an equation for the reflection of the function across the y-axis. Okay, so for a, that reflection across the y-axis means that all of my inputs become opposite of what they were. So originally, let's see, so we're going to call this g of x. Oh, actually, up here we called it h of x. So let's actually call this one h of x. It's going to be a reflection across the y-axis. And here, when we had that reflection across the y-axis, we took the opposite input. Okay, so this is really going to be f, and then the opposite of the inputs. Okay, so then what does h of x really look like? Well, every time that I see one of these inputs, x and x, I'm going to do the opposite of that. So I'm going to replace it with a negative. So I have negative x, that's getting squared, minus 8 times x, plus 17. There's no input to put with that one. All right, well, simplifying, this gives us x squared minus 8x plus 17. Now notice that we changed our input. That means that our domain also needs to change. Okay, so we're doing the opposite of our inputs, so we're going to do the same thing with our domain. The opposite of our x value is going to be in between 2 and 5. However, that basically, in order to get x by itself, I have to take the opposite of both of these and flip these signs. Probably not the best way to write this. It might be better to say, negative 5 is the smallest number. X is bigger than that. And then x is going to be less than or equal to negative 2. Okay, so this is going to be our new domain. Okay, so this is our new equation with our new domain. All right, so for b now, we're going to write an equation for the reflection of this function across the x-axis. Okay, so that's that vertical reflection that we have up here. And that's basically where we take the opposite of all of our outputs. So we'll call that one g of x because that's what we had up there. It's going to be the opposite of all of our outputs, right? F of x is another way of writing y, which is all of our outputs. Okay, so for g of x, basically you're going to take your entire function here and you're going to do the opposite of that function. So you're going to do the opposite of so distributing, we get a negative x squared plus 8x minus 17. Now, is the domain changed at all? Do I need to worry about redefining our domain? Well, I didn't deal with our domain at all. I actually did the opposite of our outputs, right, of our range, okay? So we don't need to redefine the domain. Okay, moving on to the next page. I'm going to come back to these when we actually address them. But what I'd like to do first is go ahead and start this problem. So this actually came from page 50, number 2. You're going to have a couple like these in your assignment, so I thought I'd go ahead and do them, or do one with you. And I think at this point now we can go ahead and we can do A and we can do B. And then we'll come back and talk about C and D, and that'll take us back up to the absolute value transformations. Okay, so here's our, pre-image, okay, so I gave us that, and then we've got 4 different graphs that we can then plot A, B, C, and D. Probably be a good idea to label them, so this one will be A. Okay, so for A, we're going to do the opposite of my outputs, which basically means that I have a reflection over the x-axis, right? So this is a reflection over the x-axis. So I'm going to look at all of my outputs and I'm going to do the opposite of them. So if I think about this output, for example, at negative 2, I have an output of negative 5. Well, at negative 2, if I reflect that output of negative 5, I end up at positive 5. And I'm just going to choose a few points, but it's important to get, a good graph going. Let's see, at negative 6, I have an output of 1. Well, that's going to get reflected. Now my output's going to be opposite. So it's going to come down to negative 1. At, let's see, what is this, 6, 7, 8, 9. At negative 9, I have an output of negative 4. So now that output's going to be the opposite. So at negative 9, I'll have an output of positive 4. Okay, so far so good. Let's see, at 0, I have an output, looks like negative 2. So then At 0, the opposite of -2, I'm going to have an output of +2. At 2, I have an output of 1, so I'm going to do the opposite of that and have an output of -1. And again, I'm just choosing some easy points. At 6, I have an output of -5, so I'm going to do the opposite of that, have an output of 5. And at 7, it looks like I have an output of -4, so I'm going to do the opposite of that and have an output of 4. Okay, so now connecting these dots, my graph should look like a reflection over that x-axis. Pretty close. And so basically, if I folded it on the x-axis, would this reflect, right? Is it like a mirror image? Okay, so that's A. So B now says, let's do opposite x's. So opposite x's means a reflection in the y-axis. Okay, so if you need to, you can definitely jot down some notes. So this is a reflection in x. This one's going to be a reflection in y. All right, so let's take some important points here. So for example, at 2, okay, well, let's see. And sometimes it's helpful if you make an input-output table. Because what used to be an input of 2, well, now we're actually doing the opposite, the opposite of that, right? So that means that 2 now becomes the opposite, which is -2. So I need to look at -2, whatever my output was at -2, which looks like -5. Now my new point is 2, -5. So when I go to 2, I should be down to -5. Which that is a reflection in that y-axis, right? So some of you might be able to just see it, and others of you are going to struggle a little bit, and maybe you need to write it down a little bit better. Okay? All right, so what if I do, let's take -2 now. So let's go the opposite of that. So if I start at -2, well, the opposite of that really becomes 2. And what was the output of 2? At 2, it was 1. Okay, so at -2, I'm really going to have the point, let's see, -2, 1. So really everything's getting reflected over that y-axis. Okay, so I'll do that with a couple more points, get a good idea of what's going on here. So let's see. At 6, it looks like I'm down to -5. Okay, so that doesn't really matter. 6 really becomes -6. And at -6, it looks like I'm at 1. So 6, 1 is my new point. Whereas at -6, really I should have what 6 was, right? So I should be down to -5. Let's see, I'm going to take this point too. So this was originally 5, 6, 7. Okay, so that tells me that if this is 7, I care about what was at -7. So 5, 6, 7. So that was a 0. Okay, but at -7, I care about what was at +7, the output there. And that looks to be -4. Oh, I think I messed this up. Let's try that again. So that's -6. I care about what's at +6. +6 was -5, so I messed that one up. So at -6, I should be down to -5. Okay, what else was I doing? So now I care about, that's why sometimes it's nice to have an idea of, keep your table together, because I've lost my train of thought. So I cared about at 7. So at 7, 5, 6, 7, I was down at -4. So that means that at -7, I'm going to be down to -4. Let's see, I've also got this point. So this point was 5, 6, 7, 8, 9. So at -9, I was down to -4, which means that at +9, I should be at -4. I feel like something's messed up. So where did I have a -8? I didn't. I had that at 7. Okay, I'm thinking that might be it. So again, this half is now going to be over here, and this half is now going to be over there. Okay, so I'm going to start like this, but I'm going to start it on this side. This point's going to stay exactly the same because you can't reflect it over the y-axis. It is on the y-axis, so it's going to look something like Could you do more points? Of course. And again, so then you can ask yourself, well, if I fold this over, does it appear that if I fold it over on the y-axis, does it appear that, there's a reflection in that y-axis? Okay, and it does. It does. From the pre-image to the image, it definitely does. And if you don't believe me, you can really peek your head down under there and find out. Okay. Moving on to C. So C says this new function is basically going to be an absolute value of the old function. Okay? So that means that all of my outputs, you now need the absolute value of them. So let's come up here. So what this does, and we've talked about that before, but it reflects f across the x-axis if f of x is negative. So all your negative outputs now get reflected across the x-axis. Okay, they all become positive. Okay, the absolute value of positive numbers is the same exact thing. So we don't even need to worry about the non-negative numbers. Okay, so I'm going to take every single negative output and I'm going to reflect it across the x-axis so they become positive. Okay, and I'm not going to take every one. I'm going to take all the important ones. So for example, what is that? -9, -4. Well, now that becomes -9, +4. Okay? I don't care about any of the positive outputs. Those stay the same. Okay? I'm going to take, the ones that are really obvious. So -2, -5. So I'm going to go -2, and that's going to become +5 because I'm taking the absolute value of that output. All right, here's another negative point. So 0, -2. So now that's going to be 0, +2 because we took the absolute value of the -2. Again, these are positive outputs. I don't need to worry about them. But at 6, -5. So I'm going to take the absolute value of that output. It's going to be +5. And the same thing with, I think this is 7, -4. Absolute value of that -4 gives me +4. Okay, so the positive parts still stay the same. So I'm actually going to come down to my graph, and then I'm going to stay with that graph. Then I'm going to head back up to where I have that reflection in the x-axis. Come back down to my original graph. That positive output, those positive outputs, we leave those. Okay, and then I'm going to come back up here. So it looks something like that. Okay, so everything that used to be negative is now positive. And everything that used to be positive is still positive. Okay? So let's see, this was a of x. Maybe we should label them. Go back to a, that was g of x. And b was h of x. Just for fun. All right, last one. So D. So D is where you now take the absolute value of the input. Okay, so that's up here. So what this does is it leaves f unchanged for the non-negative values of x. Duh, right? If I had originally put in 5, it's still just going to be 5. But what it does do is it reflects the part of the graph for the positive values of x to the corresponding negative values of x. Okay, so let me go over what that means. So what that's saying is, you know, let's say I plug -5 in. Well, really, that just becomes f of 5. So what's happening is all of my negative inputs are really becoming the opposite. They're becoming positive. Okay, so I'm going to have kind of this reflection of all of those positive values of x. All their outputs are now going to be the same for all the negative values of x because they become that positive there. So it eliminates the part of f for any negative values of x. Okay, so let's actually do that. And again, an input-output chart might be helpful. So I'll do one right here. Okay, so these are going to remain unchanged, okay, because, you know, the absolute value of 1 is still going to be 1. So this is still going to be f of 1, okay, whatever that output was. It looks like it's 0, okay? All right. However, if I put in -1, actually, let me write that a little bit. So when I actually put in -1, well, that really becomes the absolute value of that, right? That's what that's saying, the absolute value of your input. The absolute value of my input now becomes 1. So what was the output of f of 1? Well, it was 0. Okay, so at -1, I've got 0. Okay, let's do the same thing. Let's see for -2. So -2 now becomes, if we take the absolute value of that, becomes 2. So now I got to go to 2 and see what that output was. It was 1. Okay, so once again, what this is doing is it's reflecting the part of the graph for the positive values to the corresponding negative values of x. So you should see that there's this reflection. Look at what's happening. This graph is now going to come back up and do the same thing it was doing over here. Okay, so let me find a couple more points here just so we can be good. So 3, well, -3 really becomes 3. So the output at 3 was 0. Let's go down. 6, okay, well, -6 really becomes 6, right? So that output's going to be -5. Oops, I didn't fill this out. So at -6, I really have an output of -5. And what else do we have here? 7, so my output was -4. So at -7, that really becomes 7, my output becomes -4. So it's going to be a reflection of this positive side. So we can keep the positive piece in that. Okay, and that was v of x. Okay, even and odd functions. So we have an even function if and only if you basically can plug in the opposite of x and get out the exact same mirror image for f of x. Okay, so an even function, for example, I plug in a, I get an output out, but then I plug in the opposite of a and I get that same output out. Okay, so even functions, that's part of it. There's a lot going on, but that's one way to test that it's an even function. So it's basically this reflection over the y-axis. Another way to know that it's an even function is that if it's a reflection, both ends are either going to face up or face down, right? Because the leading coefficient is also going to be even. Okay, we talked about this in Algebra 2 quite a bit. Okay, so both sides or both ends are either going to face up or face down. It's going to be reflection in that y-axis. All right, that's the even function. Well, odd function, you can probably tell what that's going to be. So an odd function, if you take the opposite of x, that's going to equal the opposite of the output. Okay, so for example, I put a in. Okay, I get some f of a out. Now what happens when I put negative a in, or the opposite of a? I'm going to get out the opposite output, so negative f of a. Okay, so I think that's pretty clear right there. The other cool thing about an odd function, and we talked about these last year, was that your ends were going to be going opposite directions. And they are also raised to an odd power. So your leading term has an odd power.